Alright, let's see how you did on this question here. I'm going to choose to work on the left-hand side first. And when I'm looking at this left-hand side, in order to add these two fractions, the denominators are different. So I'm going to have to find the lowest common denominator. And there is no factors that are in common. It's kind of like if you're doing like 1 over 3 minus 1 over 4, your lowest common denominator is actually going to be 3 times 4. In that case, it'd be 12, right? So in our case, we're going to have to really multiply those together. So I'm going to start off and do my 1 over 1 minus the cos of theta, and I'm going to multiply that out by 1 plus the cos of theta over 1 plus the cos of theta. So that's just the first part, and then I'll say, am I getting this right here? Oh, I want the green one, minus 1 over 1 plus cos of theta, and I will multiply that out times, getting mixed up here, 1 minus the cos of theta all over 1 minus the cos of theta. Okay, so just to kind of highlight, so my original, here's my original fraction, and it's being multiplied by this value here, which is equal to 1. Right, so I'm multiplying my first term by something that's equal to 1, and then my second term here was this 1 plus cos theta, that's right there, and I'm multiplying that times something which is equal to 1. So really I'm saying this times 1 minus my other original 1 times 1. So I haven't changed the values of anything, right? So what do I get when I multiply this out here? I'm going to get 1 plus the cos of theta all over, now 1 minus the cos of theta times 1 plus the cos of theta. What happens when we multiply those together? Now that you're going to remember what it's like, that difference of squares pattern, right? So if I have x minus 2 times x plus 2, right? That's when we're going to get that x squared minus 2 squared, which is 4. So that's the same thing that we're going to get here. X squared minus 4. That's the same idea here, but we're going to get 1 minus cos squared theta. Okay, so this part here, these two multiplied together give me 1 minus cos theta. Minus, and when I multiply the numerators out, I'll get 1 minus the cos of theta all over 1 minus cos squared theta. Okay, so that's the big part there. Now we're going to put it under one denominator, 1 minus cos squared theta, and in my numerator I get 1 plus the cos of theta minus, now this whole thing is being subtracted, right? So if I think of this being in brackets right there, so, and then afterwards when I take it out of the brackets, that 1 will be negative, but my cos theta will be positive now, plus cos theta, okay? So be very careful about how this subtraction and this subtraction turns into a positive right there, okay? Now, two things I've seen going on. One is this 1 minus the cos squared of theta. Looking at my formula sheet again, this is that sine squared is going to be equal to 1 minus cos squared theta. So I'll go over here and I'll say, okay, my denominator will now be sine squared theta. And my numerator, let's see what's happened in my numerator. I have 1 minus 1. So I think my 1's are going to cancel each other out. And then I have a cos squared theta plus a cos squared theta. So I'm going to have 2 times cos theta. Okay, so notice the cos plus cos gives me 2 cos, which is different than cos squared. Okay, now I'm kind of simplified the left-hand side as much as I can. So maybe it's time to take a look at the right-hand side. So when I'm looking at the right-hand side, it's going to be equal to 2. Oh, now that's where the 2 came from, right? The 2 is looks like it's going to work 2 times the cotan of theta times the cosecant of theta. Cotan is equal to the cos of theta over the sine of theta multiplied by cosecant, which is 1 over the sine of theta. And now we see how it's going to work. 2 times the cos of theta all over sine squared theta. So now I can say that the left-hand side is equal to my right-hand side, and have successfully proved that one. So that's kind of cool. In the notes about the proof on the bottom, we can just say, note how that 2 appears. It's from the cos theta plus cos theta equals 2 cos theta. All right, now I'm not sure how that went with you last time to try it on your own, but maybe one more time I'm going to say read over the hints, the bubbles, check out example number 4, and I'll include it in my next video.